Crap.
Sorry, half of the class.
Sorry, half of the class. And James.
Especially James.
Especially James. Same first step. Draw and label the triangle. Angle A is 30. Side B is 8. What am I missing here? Oh, side C is 6. And we want angle B. We want angle B. So step 1 is exactly the same, draw and label. Step 2 is exactly the same, what are we trying to find? So I'm going to start with the sign B on top. Little b. What are we given? Ooh, we're given part of A and part of C. The notes, a handy dandy little fact about triangles. What do you remember about the 3 angles in a triangle? They make 180, so we can say that angle A plus angle B plus angle C equals 180. Mm-hmm. Doesn't work for this because it's not a right angle triangle. Okay, so I can't right away find what I want to find, but what can I find? That was I don't know, that was a weird question. So I can't jump to find B because I don't have enough here. What can I find with what I'm given? Can I find side A? Hang on. This question doesn't work because I didn't give you enough information. Hang on. Change C to A. You're going to see tomorrow this is actually the other law that you don't know yet. So change C to A and let's make that 6. That's going to be better. Change C to A. So now we have both the parts for A. How do I get rid of the 8? So just like before, isolate the variable. How do I get rid of 8? Multiply him over. Where is he going to go on that side? Perfect, so he's a coefficient. He goes in the front. In a second, yeah, you're just a step ahead of me. Don't round off here.
So I got 0.6666.
I like that. 0.6 repeating. Why does that make sense in this case?
Oh, 30, 30.
Yeah, because we're not done yet. We still have to now take what to find angle B? Sine inverse. So we're going to inverse sine both sides. So in this step, when you're finding an angle, you will have a really, really, really small number, and that's okay. Just don't round yet because it'll affect your final answer. We don't round to the end. So inverse sine, then just recall the entry on your calculator. Can I go 41.8? Yep. I like it too. It's the same steps every single time. Number 4. Angle C is 30. Side C is 5. Side B is 6. Want to know angle A. We're going to pause that. We're actually going to do some drawing. We're going to draw this one to scale and see what happens. So you need your ruler, you need your protractor. There's my protractor. We're going to use centimeters. Yeah, because inches, I don't know. 6, would it fit? It would be pretty big. Let's use centimeters.
You're saying it says centimeter on my ruler, it says centimeters on the inch side?
Clearly an American made it.
If we're just using small ones, I have a ruler.
There you go.
No, I have centimeters, so it just says centimeters.
So I'm going to start with that bottom, which was 6 centimeters. So we are trying to do this to scale, so get as close to 6 as you can. I'm going to do the angle next. So on the right side, I know it's got an angle of 30. So I'm just measuring 30 and putting a little tick here. So I'm measuring 30 and I'm just putting a little tick for now. The problem is with this side is we don't know yet how long it is. So you can either wait to draw it, or I'm just going to do it in pencil and then erase what we don't need. So I'm just making it really long for now until we figure out the other side.
Wait, sorry, can you put the protractor
Yeah.
back on? Oh, you put it.
So 30 degrees. Because it's angle C that we know is 30, so it's got to be on that right-hand side. But we don't know how long this side is because we weren't given, so either do it in pencil or wait to draw it.
I put the protractor like in the middle, and it gives me a different answer. So you have to put it at the very end of the.
That's called the vertex of the angle, is at the end.
Oh yeah.
The last side I know is 5, so now I can use what I know. Ooh, it's going to be a tiny little triangle here. So I'm just moving till the 5 is hitting that line or hitting that other side. Look how teeny tiny this is. Let's pretend I actually hit the side there. So this was our A, this was our B, this was our C, this was our 6, this was our 5, and here's our little angle of 30.
Sorry, how did you get that other one?
The last side. So I put the 0 at the A, and then wherever the 5 hits that line, that imaginary line that we hadn't really drawn yet. It's a little tiny triangle.
That was 5.
Remember the cast rule? Remember how there were 2 sines that were positive and 2 coses that were positive and 2 tans that were positive and 2 of each that were negative. Okay. Sine is positive in what 2 quadrants? 1 and 2. Okay, just keep that idea in your mind. I'm going to redraw the exact same thing. I'm going to go 6 centimeters along the bottom as again. You can't see it. There it is. I'm going to measure that angle of 30 again and just put that little tick. And again, I'm just going to draw this some arbitrary length because I don't know how long it is yet, so I'll erase it after. So we're doing exactly what we did before right now. And I'm going to put the 0 back on A and put the 5 where it was before. And once you have the ruler there, then look up, because you don't want to miss what I'm about to do. So once you have your ruler in the exact same spot, look up. What's going to happen if I change this angle at A, I'm going to hit another spot where 5 centimeters crosses this line. Watch what I'm going to do. So right now it's about 3.5. It's about 4. Approximately here is where it hits 5 again. So I'm just going to draw this a little bit longer so I can see exactly where it hits. There's about my 5. So the 6 is the same, the 5 is the same, the angle 30 is the same. What's different between these? It's angle A. There's a huge difference between angle A. Grab a different color, I don't care what color, and I'm just going to add the axes to here. So let's pretend we had put A at the origin. And if we were looking in standard position, I would mark the angle from the positive x-axis to where it hit the terminal side. And so what we get here is a Q1 triangle for the first diagram, because the angle is physically in quadrant 1. What happens with the second diagram? We get a Q2 answer. And so what it means in terms of the cast rule is from the information given in the question, there are 2 different values for angle A. From what was given here, there are 2 different triangles that we can draw with the given information. That's why the cast rule becomes really important, because when we go to find angle A, how many answers are there? There are 2. Flip the page. This is called the ambiguous case. It only happens with sine law. And it only happens when you're given 2 sides and what's called the non-included angle. So let's imagine I was given the bottom side and the side on the left, which was in the case we just did. The included angle is the angle formed by those 2 sides. So in this diagram, this would be the included angle, because that's formed by those 2 sides. What does that make the other 2 angles? Non-included. Non-included. So this ambiguous case is going to occur whenever you have 2 sides and the non-included angle. So whether we were given B or C for the question above. What it means to you is every time you're using sine law and you have this situation, you have to check if there's a second answer in quadrant 2. It's just the equivalent to what we did yesterday by getting the reference angle, the quadrants, and the 2 possible values of theta. So there's a theory behind why there's 2 possible solutions. Let's see what it means to the question. Step 1 is going to be exactly the same, label or draw your diagram and label. Step 2 is going to be exactly the same, pick the formula. What are we trying to find? Angle A, so I'm going to start with sine A on the top. What am I going to put underneath it? Little a. What am I given? So step 2 is exactly the same. Step 3 is substitution. So I'm going to keep sine A on the top. What's the problem now? I don't have little a. So this was actually the handy-dandy hint that should have come after this example. I can't right away find A, but what can I find here? I can find B. So I'm going to split the page, and I'm going to find B over here, and then I'll use B to find A. So sine big B over little b equals sine big C over little c. Sine B I don't know. Little b is. Big C is. Little c is. Step 4 is going to be exactly the same. How do I get rid of a division by 6? And where does he go on the other side? He gets tucked in front as a coefficient. Again, don't round off here. Give me all the decimals. Even? Oh, that was kind of anticlimactic. How do I find angle B? So how do I get rid of the sign? Yep, inverse sine. And let's go to nearest angle just for fun. Confirm 37. So nothing has changed so far. Here's the only part that's going to be different because of this ambiguous case. Or, what else can angle B? What else can angle B be? That's hard to say. What other value could B possibly become? So this is our Q1. How do we find it in Q2? I'm going to highlight these last two steps. That's the only thing that's different because of this ambiguous case. It's going to be with sine law. It's going to be whenever you're finding angle, just check if there's a second solution. I have marked 1,000 sine law questions. 75% of you are going to forget this step because it never happened with SOHCAHTOA, and you're so used to inverse sine, done, finish the question. You need to remember the cast rule and what we did the last 3 days in the theory, and this is why we did that theory. There's two possible answers. If we go back and look at our diagrams drawn to scale, does this one look approximately like a 37? Yeah, it's a little small because we're not quite to scale. Does this one look around 143? Yeah, it's got to be bigger than 90. That's why there's two possible answers. It's just what's given in the question. There's two possible triangles you can draw. It's only for sine law, which we'll talk why tomorrow. But we're not done because the question didn't ask for B. What did the question ask for? Angle A. So we know that 180 minus the given 30 minus the first value of B has to equal angle A. Offer of 113. Or it could be 180 minus 30 minus 143. Offer of 7? Why? It's only because we haven't drawn it exactly to scale. It would be 7 if we'd actually done it on graph paper to scale. Questions so far? B was at the top. This would have been angle A. It's pretty small. If you look, go back here. This is pretty tiny. It's pretty tiny. Number 5. Okay, tell me what to label. Or don't tell me what to label. And describe to me where side A is. And where can I find B? And what are we trying to, oh, we got another one, sorry, 36. And what are we trying to find? Right away, if we look at the triangle, I know I can't find C right away because I don't have side C. So what do I have to find first? So I don't have enough to find C. What do I have to find? Angle B first, so let's start with that. So sine of b divided by 18 equals sine of 36 divided by 12. How do we get rid of a division by 18? And where does he go? Where do I put that 18? Don't leave me hanging. Where do I put the 18? Remember, don't round off here. We only round off at the very end. That's non-rounded, 0.88. Okay, what did you get? Like that? Okay, so just double check that. Confirm.
Oh, yeah, that's right. Oh, sorry, you said not to round.
Don't round off here.
Oh, sorry.
Okay, find angle B. If we go nearest angle. Confirm to the nearest angle, 62. Or, and again, your brain's going to want to stop here because it seems natural from last year, but you need to understand Castro rule. There's a Q2 answer. Offer of 118. Nobody confirming. Are we done? No. What is the question asking for? How are we going to find angle C? Okay, so we know 180 minus the given 36 minus 62. Offer of 82. Or 180 minus given 36 minus confirm. Well, which is it, 82 or 26? Both. There's two different triangles that could be drawn from the given information. How you feeling so far on sine law? I like that the steps are always the same. Oh, word problem. Rawr, to you too. Read to read. What would you like to highlight? Another key word in that sentence. Between. Don't draw this. I'm going to show you why it's important. It's between their head. If we looked at that second triangle that we drew when we did the drawing, is you can end up with something like this, and here would be girl 1 and girl 2. But is that between their heads? No. So it's just telling you that it's situation number 1. So one girl is on this side, one girl is on this side. Okay, so ground. Do you want Alex on the left or Alex on the right? Carmen on the left then? I know, but now the A in backwards, it sees backwards from what we usually do. But it doesn't matter. She's got a string. She's got a string. Apparently it's attached to her leg. Meh. They're naked, so let's not talk about it anyway. It's all weird now. What do we know? Anybody want to fix that? Okay. What are we trying to find? Pots. We can't find B right away because we don't have angle B. We can find angle C and then use C to find angle B and then use B to find. Go to. I'll give you 4 or 5 minutes.